For part A, I would definitely fix the improper nature of the integral here by writing it as the limit as b approaches infinity, the integral from 0 to b of 1 over x squared plus 1 dx. Okay. Antiderivative of 1 over x squared plus 1 is arctangent, so we're left with the limit as b approaches infinity of arctangent, and then you could say of x and then put the bounds from 0 to b, or you could just go ahead and plug the bounds in. That's what I'm going to do. There you go. Don't forget to evaluate what you can. So arctangent of 0 is asking tangent of what angle is 0. I would go ahead and say that that is 0. And so really I'm just left with the limit as b approaches infinity of the arctangent of b. There we go. And then hopefully you are familiar with the graph of arctangent at this point. So I'll just do a quick sketch of that here. There we go. It looks something like this. And so, my friends, what would the limit as b approaches infinity of arctangent of bb? The answer would be pi over 2. There we go. Okay. Directions said determine whether each integral converges. If it converges, evaluate it. So did it add up to a distinct finite value? Yes, it did. And so I would just say, therefore, the integral from 0 to infinity of 1 over x squared plus 1 dx. And then here's a way to word this. Converges to pi over 2. There we go. All right, my friends. Okay, now if that helped you, feel like you could get somewhere with part B, then feel free to pause the video at any point, and then just kind of do as much as you can. The point that the way I do the videos is for you to be as independent as possible, as quickly as possible. So anyway, okay, so for part B, let's take a look at this one. Up to you how you want to go about this. I have a tendency, since both of our bounds are infinite in nature, yet they're opposites of each other. I kind of like doing something like this. So either use A or B. It doesn't really matter. I'm going to use A just for fun. Anyway, I'm going to let A approach infinity, but then I would just write negative A to A. That's a way to handle that. And then I'm going to write the e to the 2x part down as e to the x quantity squared. And I'm in hopes that that if you didn't see it before, that you could see that this is going to end up being an arctangent situation. And hopefully just by writing e to the 2x as e to the x squared, it makes it a little more obvious. So I'm going to let u equal e to the x, and then my du would be e to the x dx, which is right there. Okay, so let's see, what would I then have to do? Oh, goodness gracious. Thank you, moving around. Oh, anyway, sorry. I'm just going to have to leave it like this. Okay, anyway, so what would we have then? I'm going to change some bounds and stuff like that. So integrand first. So e to the x dx is just du. And then on the bottom, I'd have 1 plus u squared. And then I'm going to go ahead and change my bounds. This right here means x equals negative a. And then if you look at your primary relationship, that would mean that u would equal e to the negative a. And then similarly with your upper bound, if x was a, then that would mean u would equal e to the a, just following this relationship right here. So changing my bounds, I would have e to the negative a for my lower bound, and e to the positive a for my upper bound. Okay. Oh, goody. Okay, so now what do we have? We have limit as a approaches infinity of arctangent of my upper bound minus arctangent of my lower bound. Man. Okay, so now let's see what happens when we let a approach infinity. So like right here, we'd have e to the infinity, which hopefully makes sense. That would be infinity. And then, what happens as your input on arctangent approaches infinity? Just like we talked about in part A, your value here would approach pi over 2. Okay, now let's look at this one. E to the negative a. Well, that's 1 over e to the positive a. So on this one, if you let a approach infinity, what do you get? You get 0 out. And so you'd have arctangent of 0. So this is actually going to go to 0. So your answer would be pi over 2 again. There we go. So my conclusion would be that the integral from negative infinity to infinity of, whoops, it was e to the x over 1 plus e to the 2x dx converges to pi over 2. There we go. Oh man. Okay. Let's take a look at part C now. First, let's fix the improper nature. So we'd have the limit as b approaches infinity of the integral from 1 to b. I'm going to write the integral as 1 over the natural log of x times 1 over x dx, just because I think it might make things a little more clear as to where we're going with this. And then I'm going to let u equal the natural log of x. And then what would my du be? It would be 1 over x dx. Okay, so now let's go ahead and change this out. So we'd have the limit as b approaches infinity of the integral. Let's see, changing the bounds. If x is equal to 1, then u would be the natural log of 1, which is 0. So my new lower bound would be 0. And then my upper bound was b. If x was b, then u would equal the natural log of b. So my new upper bound is the natural log of b. And then the integrand could be replaced with 1 over u du. Okay, I'm going to go this way. Let's see. So now let's do the antiderivative of that. So we'd be left with the limit as b approaches infinity of the natural log of the absolute value of u, also known as the natural log of b, minus natural log of your lower bound, which would be 0. There we go. Okay, now this is a point in the problem where we actually come to realize that this integral was actually doubly improper. And maybe some folks noticed it before, but maybe even if you didn't, this is what it looks like to get late into the problem and to realize that you have a problem. So I hope it makes sense, my friends. Natural log of 0 is undefined, and it's not going to do us any good in a problem like this to have something that's undefined. And so at this point, we're going to go back and kind of look for a little more information from the problem that we're working on. Okay, and here's what that looks like. So first of all, you could see that you have a problem with 1 in the first place because the natural log of 1 was 0, and your integrand would have been undefined there. So even if we could have noticed this earlier, and it's okay if you didn't. You don't start erasing stuff because most of our stuff will still be able to use. But the issue is this: if you think graphically, whatever the graph of this original function looked like. At 1, it's undefined, but the good news is that we're approaching 1 from the right. So if you think about, whatever the area looks like, let's say whatever it looks like this, we're approaching 1 from the right. So that means that you've got this little like plus sign that could have been implied there simply because your area that you're finding the value of is on the right side of 1. Okay. And so down here, since you were doing, something from the right side of 1, if you think about the graph of natural log, here's 1. And if you're approaching 1 from the right, you'd be approaching 0 from above. So that has a little plus sign on it. Okay. So we're going to go through and we're going to fix our 0. So it's not actually a 0. So we'd be approaching 0 from the right. and 0 from the right here as well, which is great because we're no longer going to get undefined. Anyway, so this is what it looks like if you had an improper part in your integral and you didn't notice it until you get to kind of the stuck moment. You can get unstuck by kind of putting these little pluses or minuses in. Anyway, so we're approaching 0, but from the right of a natural log graph. And so I hope it makes sense. We'd actually get negative infinity for that part. So we'd have, as b approaches infinity, I hope it makes sense, this part approaches infinity, and the natural log of infinity is infinity. And then you're subtracting negative infinity. And so you'd end up with infinity plus another infinity, which is infinity. There we go. So we could conclude that the integral from 1 to infinity of 1 over x times the natural log of x dx diverges. And you could just say diverges, but in particular, it diverges to infinity. There we go. Woo! All right. Well, hopefully we're at least getting you to think a little bit or scratch your head or something. There we go. All right, my friends. Speaking of thinking a little bit or scratching your head, think about example 4 here. What's so improper about the integral from -2 to 0 of 1 over x dx? And what's so improper about the integral from 0 to 2 of 1 over x minus 1 dx? All right, see how it goes. Check in with me in the next video.